All right, today we're going to be talking about basic reflections. You all looked in the mirror, you know what a reflection is. Okay, now reflections are always done over a line of reflection. Now we're going to draw the reflections and we're going to label the line of reflection the LOR, line of reflection. We're going to always label the line of reflection. We're going over the x-axis. So this is your LOR, line of reflection. This original image is called the pre-image. The new image we get after we do the reflection is called the image. So we're going to reflect it. Well, when you have a point on the line of reflection, it's its own reflection. So that one stays there. The image points actually are going to be prime. So this is going to be X prime, Y prime. The little mark up there is a prime. So that one's its own reflection, but we will label it V prime. Okay, when we're doing reflections, as we saw the other day, we're going to go perpendicular to the line of reflection. 1, 2, 3, 4 to the line. So we go 1, 2, 3, 4 on the other side. And that would be M prime. For N, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that would be N prime. For E, 1, 2, 3, 4, 1, 2, 3, 4 gives us E prime. And of course, you play dot to dot. Now, somewhere I have a straight edge here. Mrs. Johnson likes my lines to be straight. So rather than make her crazy, I'll use a straight edge. And we have reflected figure ENMV across the x-axis. Now we're going to fill in the table. E started at -3, 4. It ended up at -3, -4. N started at -2, 5, and it ended up at -2, -5. M was at 0, 4, and ended up at 0, -4. V and V prime are the same because it was on the line of reflection. Okay. Now we're going to be looking for a pattern here. Notice every x coordinate stayed the same. Okay. When we're writing mappings, we say the ordered pair XY maps onto or goes on to, well, what happened? The x's stayed the same. And notice, look at the y's, 4, -4, 5, -5, 4, -4, 0, 0. The y's simply changed signs, so -y. That is a mapping. Okay? To indicate we want a reflection over the x-axis, we use R for reflection and a subscript's down below here. That means a reflection over the x-axis. And that's how we write the mapping. Okay. Number 2. Now we are going to reflect it over the y-axis. So the y-axis, I'm going to turn this here. This is our LOR. Okay? And we're reflecting over the y-axis. So point G, one to the line of reflection, one to the other side. And that'll be G prime. J, 1, 2, 1, 2. J prime. H, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that, oh, that's a W, not an H, for those of you that actually know your letters. So W prime. And N, 1, 2, 1, 2. N prime. Then, of course, we will play dot to dot. And we have reflected that figure JWNG over the y-axis. Now we have to fill in our table, of course, and we'll make an observation afterwards. So figure J went from 2, 3 to negative 2, 3. Figure W went from 5, 1 to negative 5, 1. And from 2, negative 1 to negative 2, negative 1. G prime, 1, 1 to negative 1, 1. So when we make our observation here for our mapping, we're going to take the ordered pair XY and map it onto, well, what happened? 2, negative 2, 5, negative 5. The X's simply change signs. So this mapping would be negative X. And notice the Y's did not change. Y. Our subscript, reflection over the y-axis. So far, it seems like if we know right from left, up from down, and can count, I can do the reflection. That's kind of nice because I can do both those things. I do know direction, I can count. So, and I'm fairly certain all of you can as well. The third one. Reflect across the line y equals x. Well, first we have to know what that line looks like. Well, line y equals x. I better use a straight edge or Mrs. Johnson will be beating me. Let's see. This didn't copy the best. It looks like we're there. It's a line, so of course we'll put the arrows on the end. There's a line y equals x. So if we're going to reflect, and this is our LOR. Don't forget the label. Looks like if we go up diagonally, that's got to be perpendicular line, of course. Half a square, or you can go, look, we can go up one, left one, because this has a slope of up one, right one. And perpendicular, if you remember from your 8th grade days, perpendicular lines have negative reciprocal slopes. But the easiest way, just look, we got half a line straight through, half a line straight through, x prime. A full square, a full one, c prime. 1, 2, 3, 1, 2, 3. And that would be, what is that? L prime. Okay, and then of course, dot to dot. and we reflect it over the line y equals x. Now again, let's, these of course, I forgot my primes up here. The image is x prime, y prime. So x went from 3, 2 to 2, 3. Z went from 0, -2 to -2, 0. And L went from 3, -3 3 to 1 to -3, +3. Okay. So let's make our observation so we can figure out what happened so we can write a mapping. First off, we reflected over the line y equals x. There's our subscripted form, our notation. Our mapping, well, we're going to map the ordered pair x, y onto, well, look at that. Looks to me like the x and y just simply traded places. This y or x became the y coordinate and the y became the x coordinate. So xy maps onto y, x. See, we simply switched places with the coordinates in our ordered pairs. Good. Number 4. There, oh, see, I gotta get that number 4. There we go. Number 4. Reflect over the y equals -x. Y equals -x. So that one, the line will slant the other way. Don't forget your arrows to make it in line. And this, of course, is our LOR, our line of reflection. So we have 1 1/2, 1/2, 1. Z prime goes there. 1, 2. Ooh, that's a little, well, we're going to the line of reflection, man. I don't know what I was thinking there. Let's see. 1, 2, 3 1/2, 1/2, 1, 2, 3, right here. And that is T prime. And K, 1 and 1. Right there for K prime. So then when we play dot to dot, we get that. And we reflected triangle KTZ over the line y equals -x. So let's write down our coordinates. X prime, y prime. So K went from -1, 3 to -3, 1. T went from 3 that's not T, is it? 3, 0, that is Z. This is Z right here. And this will probably be T. We'll double check. There's a typographical error there. So Z went from 3, 0, and this will be Z prime and T prime. Okay, so z prime is at 0, -3. T went from 3, 4 to -4, -3. So our subscript's easy enough. We reflected over the line y equals -x. Our mapping, let's see, we have the ordered pair xy maps onto what happened here. Looks like the numbers traded places and changed signs. So we have to change signs. So that's going to be -y and -x. Hopefully you can all see that numbers simply, if we just look at the digits, they switch places. But they also change signs. See, both these were positive. Now they're both negative and in different places. If you have any questions here, make certain that you ask, either if you're in class, of course, raise your hand, ask Mrs. Johnson or myself. If you are online, send us an email, either myself or Mrs. Johnson, depending on who your teacher is. Okay, turn the page. You've got your notes there. We'll move that one out of the way. And pull in the new one. All right. Now we're going to use what we learned to fill in the blanks. A reflection is a mirror image. This means that you reflect a figure, that when you reflect a figure, the orientation changes, like it does in the mirror. That line of reflection is also called the mirror line. See, the image and pre-image are the same distance from the line of reflection. Remember, we talked about there's the same number here. We counted down to the 4. We went down 4 on the other side. And it's distance, and distance is always perpendicular, okay? We'll talk about that more when we do the geometry unit, but it is. Okay, so the image and pre-image are the same distance from the line of reflection, but on opposite sides. The line of reflection is the perpendicular bisector, the segment connecting the image and pre-image. If you look at these, see, here's our LOR. If we do a segment between G prime and G, you can see it's a perpendicular bisector. Bisect means to cut into 2 equal pieces. Again, that's something we'll talk about a lot more when we do our geometry unit. And you can see here also, see, halfway, halfway. One on the other side. If we were to draw the line connecting them, it would be perpendicular to your line of reflection and equal on each side. So it's a perpendicular bisector of the segment connecting the image and the pre-image. Okay, now let's do number 5. Figure can also be reflected across the vertical and horizontal lines. X equals some number. Remember, if X is required to be the same, you're going to get something that looks like this, depending on where the X has to be, a vertical line. And if Y has to be equal to the same number, you'll get a line that looks like this, located wherever the Y had to be, a horizontal line. So vertical line, horizontal line. Okay? The rules are not given using mappings. So if we have a horizontal or vertical line that is not the X or Y axis, then there's no mapping rule. Okay. So, number 5. Reflect over the line X equals 1. Well, let's see. Man, we can't even see these lines. Horrible copy. It looks to me like this is X equals 1 right here. So we're going to draw our LOR. This is extremely difficult since we don't see the lines. I should have paid attention, got a better copy. In fact, I think we're going to pause right here if I can figure out how to pause. And we will, I'll make a better copy. Let's see. Pause. And okay, there we go, back to where we were. Now you can see the lines, and we want to make our line of reflection here at X equals 1. There's our LOR. Do not forget to label your line of reflection. Our pre-image is already graphed for us, so we just have to count. 1 to the line, 1 to the other side. And that would be D prime. One, two, three, four. 1, 2. Remember, we're counting to the LOR. 1, 2, 3, 4. 1, 2, 3, 4. And this is F prime. 1, 2, 3, 4. 1, 2, 3, 4. And that is E prime. And then, of course, we'll take our straight edge, play dot to dot. And we reflect it over the line, X equals 1. Now, you need to be careful here. Okay? When you're writing down your coordinates, when you're reflecting something over something that isn't the X or Y axis, be careful. Actually do the work. Here's your Y axis, not this. This is your LOR. This is X equals 1. Here is your Y axis. This is the origin. This is where you're going to count from. So D prime is at 0, 1, 2, 3. Okay? This is at, because we only went 1, 1. Okay, so that is at X prime. That is 0, -3. E prime. Here's our 1, 2, 3. So -3, -2. -3. 1, 2, 3. -2. F prime. Here's our origin. 1, 2, 3. -3. 1, 2, 3, 4. -4. Okay. Now, there isn't a mapping, but there's a subscript. R, of course, is reflection. And we went over y equals, or x equals, sorry, x equals 1. Okay. Let's see. Okay. If you have questions, again, make certain you ask in class or email it. Now, we're going to do problem 6. And we're reflecting over the line y equals 2. Remember, y equals is a horizontal. Maybe I should have written that up here. X equal, that's a vertical. And y equal, so horizontal. Okay. So horizontal at y equals 2. Okay. So y equals 2 right here. That is y equals 2. So we get your lines. And we're reflecting over that. This is our LOR, our line of reflection. Make certain you label. Okay. Now, let's see. Here's our LOR. So we have to go equal distance to the other side. So S, 1 to the line, 1 to the other side right here. That is S prime. S prime. U, 1 to the line, 1 to the other side. U prime. T, 1, 2, 3, 1, 2, 3 on the other side. T prime. And we'll play dot to dot. And we've reflected over the line y equals 2. Again, you've got to be careful with your coordinates. You see lots of mistakes on coordinates here when we reflect over a line that's not the x or y axis. So be careful. Do the work. So here's S prime right here. Here's your y axis. Here's our x axis. So here's the origin. Make sure you're counting from the origin. Count from the origin. So that's 1, 1. 1, 1. Let's see, T prime, count from the origin, be careful. 1, 2, 3, 4, 4, negative 1. And U prime, find the origin. 1, 2, 3, 4, 1. Okay, just be careful with those coordinates. I hate marking points off because we were careless and didn't find the origin. Find the origin. Okay, our subscript, R equals, well, R equals, that's not true. R subscript, Y equals 2. The line we reflected over. Okay, last one. Okay. Draw this. So we're going to plot the points. X is at 1, 3. 1, 3. Right there. X. Always label. Always label your points. Y, negative 2, negative 3. Y. Z at 0, negative 3. Z. Whoop, not Z prime, just Z. Then play dot to dot. And we have drawn that figure. Now it says reflect X, Y, Z, which we have right here, over the X-axis. Okay, well, if we're doing it over the X-axis, this is our LOR right here. The X-axis, this will be our LOR, always labeled. So it's 1, 2, 3. 1, 2, 3. So 1, 2, 3. And that is X prime. Z, 1, 2, 3, up to the X-axis. So we'll go 1, 2, 3. So we'll go 1, 2, 3, 1, 2, 3. And that will be Z prime. Not very good Z. Z prime. Y, 1, 2, 3, and you're at -2 right here. 2, 3, 1, 2, 3. It's a little harder doing it on a separate graph, but you can. We just did. Then, of course, the dot to dot. And we have reflected it over the X-axis. Now, number 9 says, now we're going to take this, reflect it over the Y-axis. Over the Y-axis. So this will be our LOR. Okay. So X prime's right down here. It goes 1 to the line, it's going 1 to the other side, right there, X prime. Z prime, and this could be double prime now because it's our second reflection. Almost forgot that. Make sure that you don't label it the same because it's different. Z prime is right there at 0, 3, and it's on the line of reflection, so it stays there. So this would be Z double prime. Y is right now, it's right here. We go 1, 2 to the line of reflection, 1, 2 to the other side, and it goes there. And that would be, of course, Y double prime. And then you play dot to dot. It's always good if you actually hit the dots when playing dot to dot. And notice what we've done. 1, 2 reflections, a double reflection, one following the other. It says you just created a composition of transformations. See, we did 2 to the same pre-image. This was the original pre-image. This would have been its image. But now if we're going to do another one, this becomes the pre-image and this the new image. When you completed 2 reflections, what other type of transformation did you create? Well, let's see. Looks to me like if we took this thing and rotated it, we get that thing. Let's see, rotate, yep, Z ends up there, Y ends up there, X ends up down, yep. So what else, a double reflection would give us the same thing as a rotation. Questions? Now that finishes up our notes for basic reflections. We'll talk more about reflections as we go and all of them, but that pretty well takes care of your basics there. Okay, enjoy it, enjoy the homework. I'm sure you will. Good luck.